welcome back. In this lecture, we're going to be discussing about Monte Carlo methods. These are a special kind of computational methods for solving certain problems for which analytical solution or numerical solution either do not exist or too difficult to implement. The history goes back to 1940s when a group of scientists, they were working on a nuclear project, and they named the project, the code name was Monte-Carlo. And so as the scientists, they discovered this technique, and Monte-Carlo name came in picture. Another thing, the name Monte Carlo, it came from a casino name. That casino was very famous, popular that time. So for some reason, they decided to give a code name to the project Monte Carlo. So enough about the history. Let's talk about what are the basic ideas behind Monte Carlo methods. We start with the pi. Okay. So what is the value of the pi? You guys might know already what is the value of the pi, which is 22 divided by 7. You guys might have learned the value of the pi in your high school. But what if I say you that from where this value came, or how can you estimate? So essentially, one thing came in picture, that pi is associated with circle. If we draw a circle of radius r and try to get the area of the circle, we say, okay, the area of the circle is pi r square, and so pi appears here. All right. Now, what if we know the area of the circle somehow, and we know the radius, so we can estimate the value of the pi. But we don't know the area of the circle, then you just plug in 22 by 7 and r square and you get the area of the circle. So the question here is how can we estimate the value of the pi? Okay, and we don't know the area of the circle either. Okay, so what if we think intuitively, what if we draw a square around this circle? Okay, so we draw this square around the circle, the length and width of the square would be equal to 2r. Okay, and if we try to get the area of this square, which would be 4r square. And now you see that we have the area of this square which contains this circle. Okay, so what if we divide the area of the circle by area of a square? Okay, so if we divide these two, then r square cancels, and we get pi by 4, and we get the value of the pi, that 4 times area of the circle divided by area of the square. The essential question is we don't know either the area of the circle or either area of a square. So what can we do in that situation? So think about intuitively what we can do. Let's say we throw some small balls. Okay, we generate these balls randomly, or we have enough number of balls, and we throw these balls such that every ball is inside this square. Okay, so as you are throwing these balls, some balls will be inside the circle and some balls will be outside the circle but inside the square. Okay, so now you got some idea that what if I start counting the balls which I'm throwing, total balls. Okay, and out of these balls, how many balls are inside this circle, and I get a probability. Okay, so probability of the balls landing inside the circle. If I calculate that probability would be equal to the area of the circle divided by the area of the square. Okay. And bingo, as soon as I get this probability, I can make use of this formula and get the value of the pi, which would be 4 times the probability. Good. So this is a basic idea about getting or estimating or approximating the value of the pi. And essentially the same idea applies to Monte-Carlo method in general terms. So let's try to formalize the concept. Okay. So we throw a ball, that ball lands inside the circle, and another ball lands outside the circle, but within the same confined boundary of the square. Okay. Let's draw some axes, and let's say the ball is ball's coordinates are xy, and it is at some distance from the origin 0, 0. Okay. So what essentially we did here, that we thrown a ball, okay, ball lands at some point xy, and that ball may land inside the circle or outside the circle. Okay. And let's say NC is the total number of balls inside the circle, and NS total number of balls within the whole area. We may call it sample space. So we can initialize the NC and NS, let's say 1, 1, and we generate, okay, a random number. Or in other words, we generate x and y coordinates of the ball randomly, and we increment value of the NS by 1, that we have thrown one ball, okay, randomly. And now we're gonna take a decision whether this ball lands inside the circle or outside the circle. Okay. So think about, if this ball lands inside the circle, then this distance from the origin of this ball, it should be less than r, which is the radius of the circle. Okay. Or if it is equal to r, it means that the ball is sitting at the boundary of the circle. And if the distance is xy, if say this ball, the orange ball, its coordinate xy, its a distance from the origin, it will be greater than r, that is radius of the circle. So with this simple comparison or simple constraint, or this simple condition that x square plus y square is less than or equal to r square, we can know that whether a particular ball or randomly generated coordinate falls within the circle or outside the circle. And if it falls within the circle, then we increment the value of the NC by 1. Otherwise, we just go to next step. Okay. Now, another thing, did we throw enough balls, or we just throw 1 or 2 balls? If we just throw 1 or 2 balls, then we may not estimate correctly, our error would be higher. So keep one thing in mind, that we can reduce the error if we increase the set of possible inputs. Okay? And here the set of possible inputs are number of balls. So that's we take a decision whether we have enough balls or not enough balls. If not, then we throw another ball and apply the same procedure, increment the value of the NS and check whether this ball is within the circle or outside the circle. Okay. And if we find that, okay, we have completed, or we have so many balls, that at every that whole area of the circle, okay, is covered with the balls, then we can estimate or calculate the probability, okay, that how many balls are within the circle out of how many balls we have thrown in total. So we get the probability, and the pi would be simply 4 times the probability. Okay. So it's a very simple algorithm, and this is the base of Monte Carlo based algorithms. Okay. The Monte Carlo methods, these are a class of computational algorithms. They provide an approximate solution in most of the cases. They rely on the repeated random sampling, as we have seen earlier that we were generating the random numbers x and y. So that is the base of Monte Carlo methods, that somehow we have to do random sampling repeatedly. Okay, and these methods are typically used when either analytical or numerical solution either they don't exist or too difficult to implement. So in these situations, we use Monte Carlo methods. What are typical applications of Monte Carlo methods? Error estimation, numerical integration, numerical simulations. For example, in high energy astrophysics, you need to do certain simulations which are based on Monte Carlo methods. Optimization, stochastic optimization, swarm intelligence, genetic algorithms, or simulated annealing based methods. So these are typical applications of Monte Carlo methods. What are the main steps for Monte Carlo methods? They are simply, first of all, we determine the statistical properties of possible inputs. Remember that Monte Carlo methods are not statistical tools. They just simply use statistical properties, okay, or statistic fundamentals. And second step, then generate as many possible sets of inputs. Okay. Third step, typically perform the deterministic calculations like we did in the previous example, that we divided. Okay, we got the probability, and then we multiplied by 4. 4 times probability is the value, the pi. So third step is perform deterministic calculations with these sets of inputs. And then finally, you analyze the results statistically. Okay. So very simple class of algorithms. I hope you guys have liked this lecture. Thank you very much for subscribing LeProfesseur on YouTube. Those who have not subscribed, please do subscribe. This helps to notify you as soon as I upload new video, new lecture. And please feel free to send me your comments, suggestions, any other topic of interest you like to have lecture on. And if you are looking for private lessons, tutoring, feel free to contact us. We are helping lots of students, and we would be happy to help you. Thank you, and have a wonderful day.